underscore here. If you are liking my contents, please do not forget to subscribe my channel and like this video and share this video. Now today we are going to discuss section 5.4 trigonometric functions defined on the unit circle. We'll start with the definition of unit circle, and the definition of unit circle is it is a circle of radius 1 unit, centered at the origin, and each point of this unit circle say this, in general this point is x comma y. Each point of the unit circle satisfies the equation x square plus y square equals 1. Remember, we had this relation between x, y and r given by this equation. If you plug r equals to 1, this equation describes the point that moves in a circle of radius 1. Now, corresponding to this part, we will solve one problem that how to show any point lies on the unit circle. So, in general, what we want to show here is the radius of the circle is 1 unit, and the radius is given by this formula on the left hand side. If this turns out to be 1, we can say that the radius of the circle is 1. So we will simplify this thing, x square plus y square. So any point is of the form x comma y, right? So 1 over 2 square plus square root 3 over 2 square. This gives me 1 over 4 plus 3 over 4. 4 over 4 equals 1. So this implies that the given point lies on the unit circle. So this is how we show that any point lies on the unit circle. So remember, whenever any point is moving on the unit circle, if the radius, if this value, if it is 1, it is on the unit circle. If this value is greater than 1, then if radius is greater than 1, it means that the point is somewhere outside the circle. If it is less than 1, the point is moving inside the circle. So this is just for the visualization. Next, we are going to define unit circle definition of trigonometric functions. But before that, let's recall so in a number line system, say we denote any real number by t. So say this is t equal to 0. On the right hand side we have positive numbers, and on the left hand side we have negative numbers. So if we split these numbers along the circumference of the circle, say let's make a circle, and so first of all let's calculate few of the values. What is pi over 4? So pi over 4 is approximately 0.8 or something like that. Please check this. And t equals to pi over 2 is approximately 1.6 maybe, approximately. So these are approximate values. Check again. So where does pi over 4 lie? Pi over 4 is here, and pi over 6 is over here. Sorry, pi over 2 is over here. So if we distribute this real number along a unit circle, say this is a unit circle, so it means this is at origin, and if any point is moving along here, so this point, if this is t equals pi over 4, so this point corresponds to here, and there is another point, say this is exactly at pi over 2, then this pi over 2 is corresponds to here, and similarly if this is another point, it will be much farther, which is, say it is t equals to 3 pi over 4, this was pi over 2. So this is how any point is moving along the unit circle. And this will be, can you guess guys, what is this? Obviously it is negative pi over 4. Now from previous section we know the relation between sine. The trigonometric functions are given, can be written as in terms of x, y and r, but on the unit circle those relation can be written in the form of, so what was sine? Sine was y over r. Since we are dealing in units on unit circle, so this becomes y. Similarly cosine becomes x over r, so it becomes again just x because r is 1. So any point, it what does this implies? So this implies that any point on unit circle is of the form cosine t comma sine t. If you are not on the unit circle and if you are on the circumference of any circle which is greater than 1, then in that case your point is r cosine theta and r sine of theta. It is a different case, but on unit circle, since r is 1, we get those values. So similarly other trigonometric functions can be derived from these two, because if we know sine and cosine, we can find other their reciprocals, their quotient values and all other things. Now let's do a problem. And find all trigonometric functions. Trigonometric, do I have any problem written over here? No. So find all trigonometric function corresponding to real number real number t associated with point p 5 over 13 comma negative 12 over 13. So how to solve this one? So in this case, since we know formula directly, we don't have to use, remember we were using the triangle, we were drawing triangles in different quadrants in previous section. So since we know now this point uh, uh, lies on the unit circle, we can directly find all the trigonometric ratios, and which are given by just x and y. Cosine is always x. So what is sine of t? Sine of t is y, which is this value, negative 12 over 13, and this is 5 over 13. Now what are the remaining? Remaining are tangent is given by y over x. Y is negative 12 over 13. Since 1 over x, right, we can take the reciprocal of x since it is in the division. So reciprocal means 13 over 5, which is negative 12 over 5. Similarly, other are the reciprocals. Remaining are the reciprocals. So I will just write remaining are the reciprocals. So based upon this, we can determine standard values of the angles associated with different points, that for example standard angles 30 degrees, 45 degrees, 60 degrees and 90 degree. I will only do show for the first quadrant trigonometric functions. So say this is 0 degree, say this is 30 degree, 45, 60 and 90 degree. So the points corresponding this point, the coordinates of these points are cosine. So first point is cosine 30, which is square root 3 over 2 and 1 over 2 sine 30. Both are equal, and in this case cosine 60 is 1 over 2 comma square root 3 over 2, and this is, can you guess, 0 comma 1, right? So this is how we can determine the standard values on and with standard values of the angles associated with a real number t of different angles. So so you can try for these uh, standard angles. So I will come up with many other problems in my next video, where we will use this unit circle and solve the problems. Until then, thank you for watching. Please do not forget to like and subscribe my channel and share this video with anyone who likes trigonometry or any of your knowns who are taking trigonometry. Thank you. Bye bye.